Okay, so we're gonna try to finish this question. We finished the first half of it. Remember in the last time, what did you do? We found the displacement just by plugging in the time 3 seconds and then 5 seconds in this position function, and then take the difference of it, and that was our displacement. And then the velocity is just displacement over change of time, which is 5 seconds minus 3 seconds, and was 24 meter per second. That was our velocity. Now we're gonna find the instantaneous velocity and instantaneous acceleration. Okay, so let's see, what is the instantaneous velocity? Again, the velocity is dx over d. Okay, okay, so let's see, position function is x equal to at squared plus b, right? So the velocity of position function is simply x prime, but we also can write dx over dt. All right, dx over dt, that's what we're gonna write. Dx over dt is actually, now let's just put the information first. What is a? A is simply 3 meter second square t square, and plus b is 10 meter, right? Now we're gonna differentiate dv dt, right? So dv dt is yes, not dv dt is gonna be dx dt. Dx dt is this 3 meter per second square t square plus 10. All right, so d dt x, d dt x is anyway, let's redo it. All right, so this is our position function. So x is actually dx dt, which we can write as d over dt x. So what is x? X is the whole thing. So d over dt is at squared plus b. All right, so d over dt is a is 3 meter per second square, and then it's t square plus b is 10 meter. Now we're gonna take the differentiate. We're gonna differentiate this. D over dt is actually, take the derivative. So 2 comes here, 3 meter per second square t, and we know that the derivative of constant is just 0. So d over dt is actually 6 meter per second square t, right? And it says when time was 5 seconds. So when time was 5 seconds, it was actually 6 meter per second square times 5 seconds. Okay, so 1 second remains is gonna be 30 meter per second. All right, so that's the velocity. Instantaneous velocity. Instantaneous velocity turned out to be 30 meter per second. All right, now we're gonna do the instantaneous acceleration. What is instantaneous acceleration? Let's see. So, all right, so dv dt can be written as d over dt b. and b is well 3 meter per second squared t. So d over dt is 3 meter second squared t. Okay. So now the acceleration is d over dt is just 3 meter per second square. Okay. So let's draw first the position function. Position function is, this is t, this is distance in meter, t in second, then the position function is this one, at square plus b is say 10 meter, so is going to be something like that. This is our position function. This is our velocity. So velocity is just this guy. This is 6 ms square. 6. This is 6. This is 6. Right? So this is 6 meter per second square t. 6 meter per second square t. If you take the derivative, you get that. Right? So d dt, and then your acceleration is that, and your velocity is that. Okay. So now this one is t second, your velocity in meters, and the velocity is 6 meter per second squared is going up. So velocity is just like that. Okay. And then finally the acceleration one. See, this is your acceleration in meter, this is your time per second, and acceleration is 6 meter per second squared. So 1, 2, 3, 4, 5, 6. So just like a straight line. So we know that when you take the derivative of the position function, you get the velocity. When you take the derivative of velocity function, you get the acceleration. And when you take the integral of acceleration, you get the velocity. When you take the integral of velocity, you take the position. So let's repeat. When you take the derivative of position function, you get the velocity. When you take the derivative of velocity, you get the acceleration. And when you, how you can go back? When you take the integral of acceleration, you get the velocity. When you take the integral of velocity, you get the position function.